Hi, and welcome to another in our series of short demonstrations of new features that have been added to MachineWorks in the MachineWorks 8 releases. Just a reminder that MachineWorks is only available as a software library. If you're interested in a ready-to-use end-user product, please contact one of our customers. In this demonstration, I'm going to talk about the MachineWorks client-server libraries that are designed to allow geometry processing and graphical updates to occur in different processes on different machines, so the two are disconnected. The main purpose is, of course, to enable cloud-based deployment and the ability to run simulations in a web browser using WebGL. But re-architecting MachineWorks to support distributed graphics has brought other advantages. It's now possible to easily integrate a MachineWorks simulation to your own graphics pipeline. Each time the in-process stock is changed by a cut, MachineWorks will pass your graphics the changed geometry, along with a notification of any geometry that should be deleted from your graphics pipeline because it's been removed by a cut or whatever. And this is all done incrementally, and so it's almost as efficient as using the native graphics provided within MachineWorks itself. Of course, in-process stock geometry is quite heavyweight data, so MachineWorks client server libraries also support fast compression and decompression, and a geometry representation that is heavily optimized for rendering. And whilst you can integrate MachineWorks into an existing client server or cloud solution, and therefore use your own communication and message passing protocols, the client-server libraries also have built-in support for TCP/IP sockets and WebSockets using JavaScript. The implementation also allows custom messages alongside the messages automatically sent by MachineWorks to drive the simulation. And finally, the libraries are flexible so that a single server can drive multiple machining sessions, and it can also support multiple clients which can either be synchronized, i.e. all viewing the same machining session, or otherwise they can be connecting to different sessions all on the same server. Okay. So first I'm going to demonstrate a nice feature enabled by the client server libraries. That's 3D recordings. So I'm running this simulation and MachineWorks is doing the material removal, doing the booleans, etc. But whilst the simulation's running, MachineWorks is also recording every frame that's being rendered, not as a 2D bitmap, but as compressed 3D information of the geometry that has changed since the last recorded frame. So in this case, I've chosen to record every frame. That's partly to slow down the playback, but I could have recorded every 10 frames or every 100 frames for a longer toolpath. I guess the point is that when you're actually playing these back, the processor has to do very little work, and so it's very, very fast. So you can put your own pauses in, etc., in your playback machine, your playback tool. But obviously, in this case, I've just decided to render every frame just to slow it down. Okay, so that's finished. Let's close this down. And here we can see we've got this recording.mw, which was recorded 9:17, which is the same time on my computer time here, and that's about 15 megabytes. So that's the compressed 3D recording. So now I'm going to run the playback, which is just being played back in a demonstration program. So this is an OpenGL based example player, and it's provided in C source code on the MachineWorks installation. So it's just an example playback that uses the client API. And you can see that I can spin it around, zoom in, zoom out, etc., all as it's playing. So it's a real, it's actually a real model in there, although, as I said, it's highly compressed. And I can even pick on the model, and it's telling me pick stock, and it's giving me a coordinate, a surface normal, which in this case happens to be up, which is helpful, and the cut number, so 9625. And you can store a variety of attribute information with the recording if you want to. So here pick another one, 3045. So this is just a basic implementation of a player. You could add standard controls such as reset, rewind, fast forward, stop on rapid feed collisions, collisions with fixtures, or all those things, etc. So that's showing that in a C-based player. But actually, if we go to the JavaScript example and load up in Chrome, so you can see here I've actually loaded a HTML file, which we'll have a look at in a second. And if I go and load in that recording.mw in here, Now I've got a few controls, which is helpful. So now we're inside Chrome and we're using WebGL and we're replaying that recording. So this is all being done on the client side. There's no actual Boolean happening here. We're just incrementally recreating the model on a frame-by-frame basis. But as you can see, it's very fast and a pretty nice result. And I can just go back, play, pause, and we could add many more controls in there. So if we just have a very quick look at what's in there. So if I look at the index.html, so here you can see that basically we've got two libraries, example.js, which is the example provided with MachineWorks that just basically does some calls into the client library, which is mwclient.javascript. So it's entirely written in JavaScript. And then there's some basic buttons here that allow you to play, pause, reset, etc. So again, let's have a quick look at example.js. So we've got fairly straightforward JavaScript, but you see here the CI is the MachineWorks client library. So for example, let's have a look at the camera manipulation. That's probably... So here we go. There's an on mouse down function, takes in an event, and then depending on the buttons, etc., it sets the view tracking mode, and then it can do a view change, etc., etc. So it's all standard stuff. So recordings can support multiple stocks, tools, holders, fixtures, and targets, but they can also support display of the toolpath, some collision highlighting, etc. So in this example, I'm just going to record a video showing you the toolpath displayed, but also this area in red where the tool inadvertently cut the fixture, which clearly shouldn't happen, and we've just marked that face in red just to highlight it. So if I shut that down, you can see the recording.mw has been updated to the current time of 9:27, and if I just play that back in the viewer, you can see, let me just make that bigger. So you can see there we have the toolpath display and we have the red highlighting. So I can click on, click on the stock and get the stock cut number, in this case 119, but I can also select the toolpath and that will tell me various information about the toolpath. So there the cut number is 72. Okay. I think I'll just show you one more example. So impeller.mw. So here's a nice recording of a 5-axis impeller I did earlier. And you can just, this time I think I only did an update every 10 cuts, or maybe actually every 100 cuts I think. But you can see this is a pretty fast preview. There's a lot of cuts going on here. There's 30,000 to 40,000 cuts in this sequence. And you can get a very quick idea of what's happening, which is really nice. And all done in the web browser, of course. Okay, so recordings are a useful and efficient way for a user to communicate ideas or problems with machining strategies or implementation or setup or whatever with their colleagues, clients, stakeholders, etc. So now let's look at a live client-server demonstration in the cloud. I've pointed my browser to a URL that actually represents a server machine in the MachineWorks offices. And now I can see a similar example interface to the JavaScript ones we already looked at. So now if I load up a file, so here I've got the model geometries being downloaded to my machine, and if I click play, I can see, if I zoom in, I can see that materials being added and the simulation's running in my browser on my machine, on my laptop sitting at home. So the key point here is all the kinematic calculations, all the collision detection, all the material removal and material addition, that's all being computed on the machine in the MachineWorks offices, and the updated geometry is being streamed down across the internet onto my laptop, and it's being rendered in the browser using WebGL. So I can't show you this in this screen recording. I'm just using Camtasia to do a screen capture, but obviously we're using here a clean JavaScript WebGL client implementation, and so it's going to run in pretty much any browser on pretty much any phone or tablet. So these modern devices are now easily powerful enough to cope with the numbers of polygons, really for anything but the very largest simulations. So if you want to, walk around a factory with an iPad and see what's actually happening on every single machine, then you can do that. It's also worth mentioning you can try out MachineWorks on the cloud by using Microsoft's Visual Cam C for Onshape. This is a full browser-based CAM system, which includes embedded MachineWorks simulation. And it allows you to create and verify toolpaths directly on your parts designed in Onshape, all using a cloud browser combination. Okay, so that's a quick overview of MachineWorks 3D recordings and also of the client-server libraries. If you've any questions, please don't hesitate to get in touch via the forums at www.machineworks.com. And many thanks for your time and for listening.